Welcome back, everyone, to Module 3 of our software development course. We will be diving into the essential topic of requirements engineering. This is the first activity in the software development process and the foundational aspect of software development that ensure we are building the right system and meeting user needs effectively. To start, we will cover functional requirements, which specify what the system should do, followed by non-functional requirements, which define system constraints and qualities like performance, usability, and security. Understanding both types is critical for aligning the final product with user expectations. Next, we will move into requirements elicitation, the process of gathering information from stakeholders to understand their needs. From there, we will look at requirements specification, where we document these needs clearly and precisely to guide the development team. After that, we will cover requirements validation, where we ensure that our documented requirements are correct, complete, and aligned with the stakeholders' goals. Finally, we will end with review question like we did in the previous module to solidify our understanding. So let's get started. I will start this module by addressing the first question that naturally comes to mind, which is what is requirements engineering? But before we answer that question, let's take a step back and ask first, what are requirements? Requirements are essentially the description of a system's services and constraints, generated as part of the requirements engineering process. They can vary widely from high-level abstract statements about what a system should provide to a very detailed and mathematical specification of functionality. For example, if we are developing a library management system, a high-level requirements might be something like the system should allow users to search for and reserve books. A more detailed requirement could specify the exact process, like the search function should allow filtering by authors, filtering by title, by genre, or by publication date. Now that we have a sense of what requirements are, let's circle back to our main question. What is requirements engineering? Requirements engineering is the process of defining the services that a customer expects from a system, along with any constraint within which the system must operate and be developed. Moving into our second question, why do we need to establish these requirements in advance? Why requirements are inevitable? Requirements are essential because they often serve two important roles. The first one, they might form the basis of a bid for a project contract. In this case, they need to be open enough to allow flexibility. The second rule is that they could also act as a foundation for the contract itself, which requires them to be defined in great details. These are often referred to as requirements, regardless of whether they are broad or specific, as they form the backbone of the project development. Let's continue with our exploration of requirements engineering by looking at the types of requirements. There are two types of requirements depending on the level of detail provided, which are user requirements and system requirements. User requirements talk about the problem domain or the user environment. They describe what effects need to be achieved. These effects are the combined responsibility of the software, the hardware, and the user. System requirements talk about the solution domain, the software environment. They describe what the software must do. They are the responsibility of the technical system and the technical developer alone. The user is not involved in these requirements. Now let's think about a practical example to clarify these concepts. Imagine a smartwatch or a health monitoring wearable. The user requirement we can think about something like continuous heart rate monitoring, notification if the heart rate exceeds a certain limit, daily summary of steps taken or distance traveled, ca calories burned. All these are related to the user requirements, what the user need. If we think about the system requirement, we should think about how to do that, not what we need to do. So if you want to monitor the heart rate, I will think about how to do that. So we will need a sensor to measure the heart rate and movement. We will need a Bluetooth capability to synchronize with a smartphone. We need a storage capacity to save this data. We need to think about the algorithms that will analyze the heart rate. So by defining both user and system requirements, we ensure that the user expectation align with the technical specification, setting a foundation for a successful product. This balance is really critical as we move forward in the requirements engineering. Let's now talk about a fundamental concept in software development, which is stakeholders. These are individuals or groups directly or indirectly impacted by the system. And of course, their feedback and the requirements are important to a project's success. We can divide the stakeholders into four categories. The first one is the end users, the individuals who will use the system day to day. Think of a cashier using a point of sale system at a grocery store. We have system managers that ensure the smooth operation of the system. For instance, think about the IT managers. We have system owners, often the individuals or entities that fund and benefit from the system. Think about Walmart or Kruger when ask a software house to implement their application, mobile application. And finally, external stakeholders. Those are outside the system operation but still affected by it. Think about a governmental organization or a group checking if a new banking software follows the rules, or a healthcare system whether following the HIPAA rules or not. Many agile methods argue that producing detailed system requirements is a waste of time. A requirement changes so quickly, so no need for it. And I don't agree with that. Or let's say I don't agree with that 100%. Yes, this is practical for business systems, but problematic for hardware and the critical systems that require pre-delivery analysis. If you are dealing with critical system, they will ask for a detailed specification before you start in the project. We have divided the requirements into two categories, system requirements and user requirements. From another perspective, we can divide the requirements into two categories, functional requirements and the non-functional requirements. Functional requirements outline what the system should do, including reaction to certain inputs and the behavior in specific scenarios. On the other hand, non-functional requirements set constraints on the system services or functions, such as timing constraints, process constraints, security constraints. In practice, the boundaries between different types of requirement is not always clear, as one requirement often impacts others. For example, a security-related user requirements, like limiting access to authorized users. It might initially seem non-functional since it is related to the security, but when we start to develop the system, it can lead to a functional requirements, such as integrating user authentication mechanism in the system. There is another category known as domain requirements, which are constraints on the system from the domain of the operation. Think about HIPAA example in the domain of the healthcare. HIPAA stands for Health Insurance Portability and Accountability Act, which is a US law that protects the privacy and security of individuals' health information and ensure it is only shared with patient consent. I like this example because I have to take the HIPAA training before start doing my research. My research focus on detecting the lung cancer from a CT scans. Before having an access to the patient CT scans, I have to go through this certification or this test, and I have to pass it before giving me an access to this information. Before jumping to the next slide, I want to mention an important thing. We usually say functional requirement, non-functional requirement, but not all people include the domain requirement as a third category here. So some people will include the domain requirements with the non-functional requirements. Let's go deeper in the functional requirements by covering more examples. I will get the examples from the case study of the Medicare systems. For example, a user shall be able to search the appointment list for all clinic. This is considered a functional requirement. It's related to a function that the system will do. The system shall generate each day for each clinic a list of patients who are expected to attend the appointment that day. Each staff member using the system shall be uniquely identified by his or her 8-digit employee number. All these tasks are related to the system function. This is why we considered as functional requirements. In this slide, I have 2 points, one to avoid and one to follow. The one to avoid is requirements imprecision. Requirements imprecision is a problem that arises when functional requirements are not precisely stated or when there is a contrast between some of these requirements. These ambiguous requirements may be interpreted in different ways by the developer and by the user. For example, consider the term search in the first functional requirement mentioned in the previous slide. The user intention is search for patient name across all appointments in all clinics. But maybe the developer has different interpretation. Let's say, for example, search for a patient name in an individual clinic. And this means that the user have to select the clinic first. This contradiction came because the requirements is not precise. Because the requirements need to be precised first. The second point that we need to follow is the requirements completeness and consistency. In principle, requirements should be both complete and consistent. When I say complete, I mean they should include description for all facilities required. When I say consistent, I mean there should be no conflict or contradiction in the description of the system facilities. Suppose, for example, you are building a hotel booking system. The requirements specify that. Requirement A says a user should be able to book a room for any date in the future. And then we have another requirement that states booking can only be made up to 90 days in advance. We have a clear contradiction here. One of the requirements say as far as you are setting the date and this date in the future to book a room, I'm okay. And another requirement say you are not allowed to pass this 90 days. So how we should solve this problem? We will try to do our best to avoid the inconsistency in the requirement. We need to make sure that the requirements are complete and consistent. But to be honest, in practice, because of the system and environmental complexity, it is impossible to produce a complete and consistent requirement document. but do your best to have it. Do your best to have it. But in practice, again, I mean, it will be very, very tough to do that. Let's return back to the non-functional requirements. Identifying which components implement a specific functional requirement is often possible. That's very easy. However, non-functional requirements implementation can be scattered across the system due to their impact on the system's overall architecture and the generation of related functional requirements. For example, when we are talking about the response time of the system, it is not related to certain component. It is related to the whole system. I need all the function to run very fast to make sure that the response time is not that high. The non-functional requirements may come from required characteristics of the software. We call it product requirements. Or from the organization developing the software. We call it organizational requirements. Or from external sources. We call it external requirements. So product requirements, which specify that the delivered product must behave in a particular way. For example, execution speed, reliability, safety, performance. All these requirements related to the product itself. Organizational requirements, which arise from organizational policies and procedures, including process standards and implementation requirements. We have external requirements, which are driven by factors outside the system and outside the development process, such as ethical guidelines. Let's have an example from a hospital patient management system. I will tell you some requirements and let's think together. This requirement is product requirements, organizational requirements, or external requirements. The first one, the system must respond to user actions within 3 seconds to ensure smooth performance for healthcare providers during patient care. This is a non-functional requirement, and it's clear that it is related to the product itself. The system must comply with the hospital security policies. You care about the policy of the hospital, which is the organization that are developing this software. So I will consider it as an organizational requirement. Finally, the system must adhere to HIPAA regulations. This is related to another organization which is outside organization, so I will consider it as an external requirement. I hope the difference between these three requirements is clear. Again, your requirements must be clear, must be unambiguous. I will add that it must be also measurable. We need to find a way to measure if these requirements are accomplished or not. Other than that, we will start facing problems with users when we are delivering our system. Let's check this statement and let's decide whether these statements are good or bad, clear or ambiguous. The system should be easy to use by medical staff. What do you think about this statement? This statement is ambiguous. You don't like this statement. You shouldn't include something like this in your requirement specification. Why? You said it's easy to use. How we will measure how easy is it? There is no way to do that. This is why I said it's unclear and this is ambiguous statement, unmeasurable statement. Let's check the second one. The system should be organized in such a way that user errors are minimized. What do you think about this statement? This statement also unclear, very ambiguous, unmeasurable. You said minimized. How I will know that it is minimized or not? There is no metric, there is no measure that tell us we achieved this accomplishment. we achieved these requirements. See how I change this statement. Medical staff shall be able to use all the system functions after 4 hours of training. Do you see how it is measurable right now? I will get the system users, I will give them a training, 4-hour training, and after that I expect that all the user will be able to use it. If they are not able to use it, then you didn't achieve your goal. So now I have a measurable requirements. The second one, the average number of errors made by experienced user shall not exceed 2 per hour of system use. So I expect the number of errors to be 2 errors per hour. So now I have something to measure. If you make more than 2 errors, then I have a problem with the systems. If you didn't exceed these 2, then your system is in good shape. So that way I'm changing the non-functional requirements that are unclear, ambiguous, and non-measurable to a clear and unambiguous and measurable requirements. Let me suggest a way to avoid these unmeasurable requirements. Typically, when we discussing non-functional requirements, we focus on aspects like safety, speed, size, portability, ease of use. If we are talking about speed, most probably the user will think about saying something like this: I need a fast system. All of us need a fast system, but how fast is it? So I will not accept something like this. I need a fast system, but I will ask the user to specify how fast is the system. I will accept requirement like this. System speed should be 20 transactions per second. Now I have a measurable metric for this speed. If the system after development pass this speed, I'm in good shape. If not, then I am facing a problem and I need to work on this system again or try to enhance the my product. If we are talking about size, the user may think I need a large storage, but we don't have large storage. How large is that storage? So I need to say I need 5 ROM chips, each one is 100 megabyte. Now I specify the storage. Portability. You may say I need the system support many platforms. What do you mean by many platform? What is the platform? How many platform? And what is exactly the platform that you need the system to support? I will accept something like I need a system to support Windows and Mac OS. It is clear. I have 2 platforms that I need to support. Ease of use. I need easy to use system. How easy is that system? Like we did previously, I need the training time to be 18 hours. That means the system is easy. I will train the users for 18 hours, and after that I expect from the user to be able to use it. If they are struggling, then I have a problem in my system. If they can use it, then I achieved the goal. As we mentioned before, the requirement engineering process consists of 3 main activities, which are requirements elicitation and analysis, requirement specification, and requirement validation. Let's talk in details about each activity, and let's start with requirements elicitation and analysis, or sometimes they call it requirements discovery. In this activity, technical team is joining hands with customers to deeply understand the world of the needed application. Together, they will pinpoint the exact services the system needs and its limits. And guess what? When I said customers, I mean all the system stakeholders, like end users, managers, maintenance engineers, domain experts. Everyone related to the system should be involved. The process model for requirements elicitation and analysis consists of 4 key stages. The first one is the requirements discovery. Interactions with stakeholders are used to understand the requirements and the system domain needs. Then we will have the requirements classification and organization that involves organizing the collected requirements into coherent groups. Then we'll have requirements prioritization and negotiations that involves resolving conflicting requirements among stakeholders through negotiations and ranking them in terms of importance. And then we will have the requirements specifications that involves recording the agreed upon requirements for future reference. I want to add here that this process is iterative, which means it will involve continuous feedback. And it is essential to have regular stakeholder meetings to ensure all concerns are addressed. Once done, we will have our output requirements documents, which will act our constitution. This is the things that we agreed with the user. If we have any problem in future, we will return back to this document. In this stage, I encourage you to use simple language and diagrams. So instead of having complicated stuff in the documentation, no, I will use a very, very simple language and very, very simple diagrams that can be understood by the users and by the developer. This will improve the understandings, and we can use for this any shared document platform. Sometimes they call it wikis, like Google Drive, OneDrive. That way we can facilitate easier information sharing among the stakeholders. Let's now talk about requirement elicitation techniques. There are two different techniques. The first technique we employ is interviewing. It is more than just a chat. It is a structured conversation where we engage stakeholders, understanding the rules, tasks, and vision. However, it is not without challenges. Sometimes our specialists might use terms that seems alien to our requirements team. At times, stakeholder might omit details. They find basics, but for us it is very important and we are not familiar with it. Let me tell you a funny story here. From when I start learning radiology terms, I was still very much in my engineering mindset. So I'm sitting with this radiologist looking at a lung scan, and he says, there is some calcification here. Now, to me, as an engineer, calcification sounds like we were talking about concrete. So I ask him, totally serious, calcification? Are we talking concrete in the lung? He starts laughing and says, not quite. No cement needed. It just means there is some hardening in the tissue, not actual building material. After that, it became our little joke. So you need to take care. Sometimes we use term for us have a meaning, but from the business views, it has a totally different meaning. Now let's move to our second technique, which is ethnography. Picture this: immersing ourselves in the environment, watching people in their natural work habitat to grasp how they utilize various tools and artifacts. The problem with ethnography is that it studies existing practices, which may have some historical basis, which is no longer relevant. So we need to be very cautious here. Is that really what we will build, or we are building different system? We are trying to replace the old system with a new system, with a new technique, or with a new ideas. On this slide, we are looking at scenarios and user stories, which are powerful tools in understanding how a system will be used in real life. Essentially, scenarios and user stories provide concrete examples of how people might interact with the system to accomplish specific tasks. These descriptions are incredibly useful because they are based on realistic and practical solutions that stakeholders can relate to. This makes it easier for them to envision how the system will fit into their own daily tasks and process. When stakeholders see a user story that mirrors their situation, they are more likely to give meaningful feedbacks, helping us refine and adjust the system to meet their actual needs. Now let's move on to the next activity, which is requirements specification. Requirements specification is the process of documenting the user and system requirements in a structured document. Here, user requirements need to be written in a way that's understandable to end users and customers who may not have a technical background at all. In contrast, system requirements are more detailed and often include technical information that guide the development team. There are multiple methods for writing system requirement specification. I will start with the first one, which is natural language. Here, requirements are written in a numbered sentence using plain language, with each sentence expressing a single requirement. Then we have a structured natural language. Here, requirements are written on a standard form or template in natural language. We're still using the natural language, but we're trying to use this natural language to fill a certain form or certain template, where each field of the form provides specific details about an aspect of the requirements. We have graphical notations. Graphical model often with text annotations are used to outline functional requirements. Common tools include UML use cases and sequence diagrams. Today we will see an example for UML use cases, and in the following modules I will show you multiple examples for these use cases and for sequence diagrams. And finally, mathematical specifications. These are based on mathematical concepts like finite state machine or set theory, providing a precise, formalized description of all the requirements. Each of these methods has its strength and is chosen based on the project's needs and the stakeholders involved. If you are planning to use natural language to specify your requirements, I have some key advice on this slide to help make your requirements clear and effective. The first one is to use a standard format. Establish a standard format and apply it to all requirements. This keeps everything consistent and easy to follow. The second advice is to use a consistent language. Be mindful of the words you choose. Use shall for mandatory requirements and should for desirable ones to clearly distinguish between them. Highlight key parts. Use text highlighting to emphasize the most important element of each requirement, making them easy to identify at a glance. Avoid computer jargons. Keep the language simple. Try to avoid technical terms so that even non-technical stakeholder can understand the requirements. And finally, add rationale. Include an explanation of why each requirement is needed and note who proposed it. This will make it easy to know who to consult if clarifications is needed. Following these guidelines will help ensure that your requirements are clear, precise, and accessible to all stakeholders. When using natural language for requirements, a few common issues can arise. The first one is lack of clarity. It can be challenging to balance precision with readability, which often lead to vague or unclear statements. The second problem is requirements confusion. Functional and non-functional requirement can easily get mixed up, making it difficult to distinguish between them. And finally, requirements amalgamation. Sometimes multiple requirements are combined into a single statement, which can lead to misunderstanding and make tracking individual requirements harder. Addressing these issues is important for creating a clear and effective documentation. Let's now jump to structured natural language, which is a technique for drafting system requirements in a standardized and consistent format, rather than using the free form text that we are using in the natural language. This method combines the readability of the natural language with the clarity provided by a structured template. When using standard format to specify functional requirement, the following information should be included. A description of the function or entity being specified. Details on its input and where they originate. Information about its output and where they should go. Any data or other entities needed for the computation. A description of the action to be performed. And finally, any side effect of the operation if applicable. By including these elements, we ensure that each requirement is clear, complete, and easy to understand. An example of graphical notations in requirements is use cases, which are now an essential part of the UML. By the way, UML stands for Unified Modeling Language. Use cases are tools that help illustrate interactions between users and a system using both graphical model and sometimes a textured text. In a basic use case, we identify the actors, which can be human users or other systems, and name the type of interaction involved in this process. These use cases are essentially scenarios included within UML that shows possible interaction with the system. A complete set of use cases should cover all interaction with the system and can be supplemented with more detailed, like tabular description if that needed. To add even more details, we can have something called UML sequence diagram, but we will not cover it today. So let's now see an example for a use case. The following figure illustrates some of the use cases of the Mint Care system. You can see here different actors like manager, doctor, nurse, medical receptionist. For example, the doctor has an access to view record, edit record, set up consultation, while the nurse can view and edit the record but cannot set up a consultation. To view the personal information, you can see that the medical receptionist have an access to this, and the manager, but doctor and nurse does not have an access to view personal information. And as I mentioned, use cases are typically combined by descriptive text. Here is an example of a text-based description that corresponding to this figure specifically describes a setup consultation use case. Setup consultation allows two or more doctors working in different offices to view the same patient record, blah, 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 and all these details. I want to add here some practical notes. Use cases can be too fine-grained to discuss overall requirement effectively. And this is why some people prefer to use it in system design than in the requirement engineering. And another point that stakeholder may not fully understand the term use cases. This is our term, this is our jargon, but stakeholder are not familiar with this term. And sometimes they will find the graphical model are not that useful. But for us, it is useful because it will help us understand the business or the logic of the application. The software requirements document, sometimes called the Software Requirement Specifications or SRS, is the official statement of what is required of the system developers. It should indicate both a definition of user requirements and specification of the system requirements. Again, it is not a design document, it's an analysis document. So, as far as possible, it should set of what the system should do rather than how it should do it. Again, it's an analysis document, not a design document. I will focus on what the system should do, not how the system will do it. The structure of the requirement document include something like preface. This should define the expected readership of the document and describe its version history, include a rationale for the creation of a new version if we have a new version, and the summary of the changes made in each version. We have introduction section. This should describe the need for the system. It should briefly describe the system functions and explain how it will work with other systems. Glossary. This should define the technical term used in the document. User requirement definition. Here you describe the services provided for the user. The non-functional system requirement should also be described in this section. And this description may use natural language. You can use diagrams or any notation as far as it will be understandable by the customer. I mean, that's fine. We will have system architecture. This chapter should present a high-level overview of the anticipated system architecture. System requirement definition. In system requirement definition, we should describe the functional and the non-functional requirement in more details. System models, this might include graphical system models showing the relationship between the system component and the system and its environment. System evolution, this should describe the fundamental assumption on which the system is based and any anticipated change due to the hardware evolution, changing user need, and so on. Appendices, this should provide detailed about, let's say, the database we are using, some information, some description of this database, some description of the hardware that we have. And finally, we'll have an index. Note that for system developed incrementally, the requirements document usually contain less detail. And sometimes we don't have this document, or let's say we will have it, but not in that formal way. On the other hand, for critical system, I mean the application necessitate a comprehensive requirement because we need to deal with safety and security, and this is a big issue. We need to make sure that all the potential requirements is correct and there is no space for any errors. Our final activity is requirements validation, which is focused on ensuring that the requirements accurately define the system the customer truly wants. It is important to note that requirements error are costly. Fixing requirements error after delivery can be up to 100 times more expensive than fixing an implementation error. This is why validation is so crucial. During the validation process, we should check the following. Validity. We need to ask ourselves, does the system provide the function that best supports the customer's needs? Consistency. Are there any conflicting requirements? Completeness. Are all functions required by the customer included? Did we include in the requirement specification document all the user requirements that we agreed on during the requirement elicitation meetings? Realism. Can these requirements be implemented within the available budget and technology, or it's just out of the user dream? Verifiability. Can we test and verify each requirement? Are these requirements measurable? All these checks help ensure that the requirements are accurate, feasible, and complete before moving forward. Several techniques for requirements validation can be implemented either alone or in combinations, such as requirements review, which is systematic manual analysis of the requirements. Prototyping, we covered this technique in module 2, using an executable model of the system to check requirements with the stakeholders or with the end users. Test case generation, and the goal of this technique is to develop tests that confirm whether the system behaves as expected according to each requirements. In practice, there are a few important points about requirements validation. First, not all issues can be detected during validation. Some gaps only become apparent once development starts or the system is in use. For example, a patient management system might initially meet a clinic's needs, but if the clinic expands services, new requirements may emerge and that weren't anticipated. Second, adjustments are often needed even after finalizing the requirements document. Sometimes the stakeholder interpret features differently, or certain details are missed. This is why requirements engineering often requires ongoing flexibility and communication with the stakeholders to ensure the final product align with all their needs. Now that we have covered the final activity in the requirements engineering, you should have a solid understanding of the key concepts. With this foundation, you are well equipped to apply this principle effectively. So let's try to apply what we have learned today in the following review question. For this project description, identify the functional requirement, the non-functional requirement, all ambiguous description of the requirements, if any. Identify the project stakeholders. Let's pause the video for a moment, carefully read the software description, and try to list all the functional requirement, non-functional requirement, ambiguous requirements, and identify all stakeholders involved in this software. Let's go through this system description together, one statement at a time, and identify the types of requirements we see. This software is developed for a comprehensive healthcare management system in a metropolitan city. I believe the first statement does not belongs to any kind of requirements. It's not part of the requirements. So let's go to the next statement. The system will record patient details, their medical histories, and current medical conditions. This is a functional requirement. It defines what the system should do, specifically recording patient information, which is a core function of that software. Healthcare providers can access the system to update treatments, prescribe medications, and schedule follow-up appointments. Here we have several functional requirements as well. Each action, updating treatments, prescribing medications, and scheduling appointments, describe what the system should enable healthcare providers to do. Patient can log in to view their medical records, upcoming appointments, and manage their personal details. Again, this is a functional requirement. It outlines the actions that patients should be able to perform, such as viewing a record, checking appointment, and managing personal details. Let's go to the next statement. The software also integrates with pharmacies, allowing instant prescription transfer. This is another functional requirement, since it describes an interaction between the system and external pharmacy systems for transferring prescriptions directly. This system is to be developed over 18 months using C#. Here we are looking at a non-functional requirement. The timeline and the programming language uh, uh, don't describe what the system does, but rather the condition for its development, specifically the project duration and the technology choice. It must adhere to the National Health Service Standards (NHSS) and the Medical Record System (MRS) protocols. This is also non-functional requirements. To be honest, it should be a domain requirement, but as I mentioned at the beginning of this video, that sometimes we combine the domain requirements with the non-functional requirements. So here, let's say, because we don't have a domain requirements category, so I will consider it a non-functional requirements, because it needs from us to adhere to these protocols, ensuring that we meet certain required standards. The development team must be on board on a full-time commitment. This is another non-functional requirement. It is specifying an operational consistent for the development process, requiring a full-time commitment from the team. And finally, this software must ensure the utmost confidentiality of patient data and should be available 24/7. Here we have two non-functional requirements. Confidentiality: the system must protect patient data, which involve implementing security measures to ensure data privacy. And the second statement talk about the availability requiring 24/7 availability, means that system should be high uptime with minimal downtime, which could impact its design and infrastructure. Now, after we went through the core requirements of the system, let me ask you, did you notice any ambiguous requirements? Don't forget, ambiguous requirements are those that are not fully clear and may lead to misunderstandings. Let's go over a few examples together. Full-time commitment for the development team. The term full-time can mean different things. It can mean 40 hours per week, 30 hours per week, 24/7 availability for emergencies, or complete focus on this project alone. To make it clear, we could specify more details. Let's say the development team must allocate at least 40 hours per week to this project and be available for immediate issue resolution within work hours. I add a meaning for the term full-time that is measurable. Also, utmost confidentiality of patient data. This phrase is vague about the specific measures needed to ensure confidentiality. To remove ambiguity from this requirement, we might specify certain security protocol, like data must be encrypted using a certain encryption protocol, and I will name this protocol, or only authorized personnel may access patient data, and I can say they have to access this data through a multi-factor authentication, for example. 24/7 availability. This requirement states that the system must be available around the clock, but it doesn't specify acceptable downtime or scheduled maintenance window. We could clarify this by saying the system availability must be an uptime 98%, 99%, or whatever, with a planned maintenance occurring outside of the peak hours. Instant prescription transfers to pharmacies. The term instant is not clearly defined. Are we talking in seconds or we are talking about minutes? We could remove this ambiguity by specifying the prescription should be transferred to the pharmacist within 30 seconds, within 5 minutes. And finally, I noticed that the patient can manage their personal details. It's not clear which personal detail patients can update. Will you allow them to update their names, their social security, their date of birth? I don't think so. So you need to clarify this requirement by saying patient can update their contact information, such as phone number, addresses, but cannot modify their medical history or treatment records. They cannot modify their names directly. They have to do that through the personnel that can do that in the system. By specifying these details, we make the requirements clearer and avoid potential misunderstanding during the development and testing. Now let's move on to the stakeholders for this system. Here is a list of everyone involved. Doctors, nurses who will use the system to update treatment and manage patient information, patients who will access the system to view records, check appointments, manage their personal details. Pharmacists who will receive prescriptions directly from the system. NHS and MRS, which are the regulatory bodies ensuring that the system meets the healthcare standards. And finally, we have the software team, often the forgotten stakeholders. Yes, that's us. We are responsible for interpreting, developing, and maintaining the system to ensure that it meets all these requirements. I believe that's all I have for you today. Thank you for watching the video. I hope you found it helpful. If you have any questions, please don't hesitate to reach out. Good luck with your midterm and see you next week. Bye bye.